Assalamu alaikum. My name is TAREQ RUBAIDI from RK85. Right, what causes stent stenosis? Well, actually, stenosis was a result of response over the vascular tissue to the injury caused by coronary angioplasty. In the case of stent stenosis, it's a result of vascular injury that occurs after the stent. What would actually happen during the stent stenosis? There are some causes will close the coronary arteries. Over the time, the artery is subjected to the pressure of cells outside of the stent stenosis, which leads to stenosis within the stent, and that actually decreases the amount of blood flows into the arteries. To talk about the approaches, I would like to pass to my friend Mika.
Hello everyone, thank you Tareq for the previous explanation. Hi, my name is SUSHMEEKA PRATHABAN. I'm here today to explain on 4 approaches to overcome stent stenosis. The first one is drug-eluting stent. Drug-eluting stent is gradually released into the blood vessel to prevent it from being blocked again. It also promotes a good blood flow and also relieves chest pain. The second one is vascular gene therapy. Vascular gene therapy potentially controls cellular growth related restenosis by modifying gene expression. In a porcine model of restenosis, intramural delivery of specific antisense oligonucleotide completely eliminated C-mic expression. Now I'd like to go with the third one. The third one is debulking device. Debulking device such as directional and rotational atherectomy is also an approach to overcome this problem. The last one is intravascular brachytherapy. It is believed that intravascular brachytherapy will let patient go longer without restenosis. Patient who receive radiation had less late loss of lumen and also reduced restenosis rate. That's all from me. Thank you so much. And I would like to pass it to my friend KHALIS Daniel for his explanation. Thank you.
Thanks to Mika. I will take from here. Question 3. How to conduct the biological evaluation of the stent? First, we have to categorize first our medical device, which are implant medical device, contact with blood, and long-term duration. Hence, we know the following are our tests required, which are cytotoxicity test to determine the cell death rate, will be conducted under ISO 10993-5 sensitization test to estimate the potential for contact sensitization, and orientation reactivity test to estimate the orientation potential of medical device. Both will be conducted under ISO 10993-10. Next will be material mediated pathogenicity test to detect the reaction of material mediated pathogeny, and then acute systemic toxicity to estimate the potential of harmful effect under 24-hour, subacute and subchronic toxicity test to determine the reaction under 24-hour to 10% of the lifespan for subacute and 90 days for subchronic. All of this will be conducted under ISO 10993-11. Next two will be chronic toxicity test to determine the effect of exposure to medical device in the lifespan. Will be conducted under ISO 10993-11. Implantation effect test to assess the local pathological effect will be conducted under ISO 10993-6. The last three will be hemocompatibility test to evaluate the effect of the blood contacting medical device will be conducted under ISO 10993-4. Genotoxicity test to assess the potential for gene mutation will be referred under ISO 10993-3. The last one will be carcinogenicity to evaluate the carcinogenicity of medical device will be conducted under ISO 10993-3. For the next question, I will invite my friend Zakirah.
Assalamualaikum warahmatullahi wabarakatuh and good day. Thank you to my previous team members, KHALIS, for the explanations on question 3. Now, I am Zakirah Zaludin. I'm going to talk and explain about the question 4, which is coronary stent design and their mechanical properties. For this coronary stent design, where as we know that the Julio Palmas and interventional vascular radiologist is known for inventing the balloon expandable stent, for which he received a patent filed in 1985. This patent has been included on the list of the 10 most important inventions of all times. Coronary stents are now used in nearly all angioplasty procedures. The stent is a tiny, expandable metal mesh coil. It is put into the newly open area of the artery to help keep the artery from narrowing or closing again. Once the stent has been placed, tissue will start to coat the stent like a layer of the skin. Stents are classified as coiled or slotted tubes or modular. This is the design of the coronary stent that I had made throughout the solid work, which is the coil stents are made of the wire that are formed into a circular coil to form the stent scaffold, while the slotted tube stents are constructed from a metallic tube and then laser etching is used to cut out the design. Coronary stents represent a key development of the treatment of obstructive coronary artery disease since the introduction of percutaneous coronary interventions. Initially, stents platforms used biologically inert stainless steels resistant stents performance due to limitations in flexibility and strut thickness. Later, cobalt chromium stents allow outperform steel as the material of choice for stents, allowing latest generation stents to be designed with significantly thinner struts while maintaining corrosion resistance and radio stents. For this design, it requires a wider pitch focus range to minimize recoil, short segments for improved conformabilities and minimal gaps on the bend, helicals to connector design engineered for maximum flexibilities and conformance to the vessels, and also nested peak to avoid strut-to-strut contact on bends. For the exceptional axial strength, it's up to 1.4 greater axial strength, superior radial strength up to the 136% higher radial strength, and also the outstanding flexibility up to 9 times more conformables, significantly less vessel straightening, and also best in class visibility built using the PICR alloy. Platinum has over 2 times the density of irons or cobalt. Next is the chemical properties. Well, the first one is nature, which is usually used by the oxide, nitride, oxynitride metals, carbon-based materials, and also polymers. Second is the deposition methods such as pulse, laser depositions, and also the magnetron sputtering. And the last one is the coating properties, which is its protective, anti-adherence, antimicrobials, and anti-biofilm activity that control drug release. That's all from me. Thank you. And now I'm going to pass it to my next team members, SITI, NORHIDAYAH.
Thank you, Zakirah, for the detailed explanation about our design and chemical properties.
My name is Siti NORHIDAYAH MUDA binti IBRAHIM.
I'm going to continue this presentation about morphological and mechanical properties. For the morphological properties, the first is about size. Coronary stent's length should be 15.45 mm in BMS, and the stent's diameter should be 3 mm in BMS. The number of stents required is just only 1.58 for BMS per patient. Second is the shape of the coronary stent. The coronary stent should have the tube-shaped device that will be placed in the coronary arteries. It will be functioning as the blood supplier so that the arteries can keep open in the treatment of coronary heart disease. Next is the mechanical properties of the coronary stents. The material we use in this coronary stents is cobalt chromium. The first one is it has a higher radial strength and the higher radio opacity for similar electronegativity. The next one is the corrosion of this coronary stents is high. It is a low wear material so that it can be used for a long time. The hardness of these alloys range between 550 and 800 MPa. It also has a tensile strength between 145 to 270 MPa. Lastly, it has multi-phase structure and precipitation of carbide. That is all from our group. Thank you.